Question number 27. The diagram below represents a standing wave produced in a string by a vibrating wave generator. Remember, a standing wave looks like that it's not moving, and that's because we have something called nodes and antinodes. Nodes are where the spots are together, where there's destructive interference occurring, and it looks like the wave is not moving at all at those locations. Here, however, we have the antinodes. The antinodes are the part of the wave that do move back and forth. How many antinodes are shown in this standing wave? Well, I have 1, 2, 3 antinodes. It's as easy as counting 1, 2, 3. Question number 28. The Doppler effect is described as what? Well, Sheldon, how about you describe it for us?
It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
So the Doppler effect deals with the shift in the observed frequency between the sound source and the observer. Thank you, Sheldon. Question number 29. The diagram represents diffraction. Remember, diffraction deals with the bending of waves around an obstacle. Typically, the diagram that they show you looks like this. You have your waves coming in, and they would bend around that particular opening just like that. In this case, what can we eliminate? Well, 3 is reflection, so 3 is out. 4 is reflection, 4 is out. 2, no, these waves should have a bent curve to them in choice 2. That is not there, which leaves us choice 1 as our answer. Question number 30. We're talking about forces that exist in the nucleus. The forces that exist in the nucleus are going to be the strong nuclear force. And we're also going to have, if we think about the nucleus, where we have protons inside of that nucleus, those protons don't want to be there. They want to separate apart, but they can't separate apart because of the strong nuclear force. But a proton and a proton, these little guys here, don't want to be together. Those little guys want to repel away from each other. That's the electrostatic force. So that electrostatic force is beaten by the strong nuclear force. So what do we have? A repulsive electrostatic? That makes sense. And a repulsive gravitation? No. A repulsive electrostatic? Yep. And an attractive strong nuclear force? There you go. The nuclear force keeps it together. Question 31. A meson could be composed of. Well, what the heck is a meson? Sounds like I need to go to my reference table. If I go to my reference table and look for the word meson, I'll find it right here under the classification of matter. So we notice matter is made up of 2 things, hadrons and leptons. The hadrons are broken down into 2 categories. One category is a meson, and a meson is made up of a quark and an antiquark. Now that I know that it's made up of a quark and an antiquark, I'm going to have to look at the combinations that they give me under the section here of a quark. I'm only allowed 2, a quark and an antiquark. It says a top quark and a bottom quark. Let's take a look. Top quark, but it says a bottom. Bottom's not anti, so that's not it. So nope, that's out. An electron and an anti-electron. Well, electrons are leptons. No, I need a quark and an antiquark, so that's out. A strange quark and an anti-charm quark. Let's see, are they both on the list? Strange quark and a charm, but it says anti-charm. Ding, 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 that's a quark. That's an antiquark, so 3 is my answer. Go ahead and get your fix. Try page 6. Or if you want to try to get a higher score, redo page 4. Get yourself pumped. It's physics. Let's get it.